Okay, now we're at 1.4, other effective sampling methods. Remember last time we talked about the simple random sampling, okay? But remember, the goal of sampling is to obtain as much information as possible about the population at the least cost. And cost includes monetary outlays, time, and other resources. So with this goal in mind, we may find it advantageous to use sampling techniques other than simple random sampling. And so one of those is a stratified sample. A stratified sample is obtained by separating the population into non-overlapping groups called strata, and then obtaining a simple random sample from each stratum, singular, plural, right? The individuals within each stratum should be homogeneous or similar in some way. Here's an example. In 2008, the United States Senate had 47 Republicans, 51 Democrats, and 2 independents. The president wants to have a luncheon with 4 Republicans, 4 Democrats, and 1 other. Obtain a stratified sample in order to select members who will attend the luncheon. So to get a stratified sample, you're going to conduct a simple random sample within each group. That is, obtain a random sample of 4 Republicans from the 47, a simple random sample of 4 Democrats from the 51, and a simple random sample of 1 other from the 100. Be sure to use a different seed for each stratum. So in both simple random sampling and stratified sampling, because stratified sampling involves simple random sampling, then you need a frame. Remember what a frame was? It's a list of the individuals in the population, right? So you've got to have some list. To do this, we'd have to have a list of all these names and their political affiliation. Therefore, these sampling techniques require some preliminary work before even obtaining the sample. So a sampling method that does not require a frame is, wait for it, a systematic sample. It's obtained by selecting every kth individual from the population. The first individual selected is some random number between 1 and k, right? And here's an example. A quality control engineer wants to obtain a systematic sample of 25 bottles coming off a filling machine to verify the machine is working properly. Design a sampling technique that can be used to obtain a sample of 25 bottles. Okay, so he needs to randomly determine a number between, say, 1 and 25, and then he just picks every 5th bottle. But the question is, how do we determine that K, right? So here's steps in a systematic sampling if the population size is known. So he should know how many bottles come off of that machine a day, right? So step 1, if possible, approximate the population size, and remember that's capital M. Determine the sample size desired. He wanted 25. Compute the population divided by the sample, round down to the nearest integer, and that's where you get your K from. And then you randomly select a number between 1 and K. Let's call that P. So before we said 5. So then he's going to sample the 5th bottle, right? The 30th bottle. Okay, 5 plus 50, the 55th bottle. On and on and on until he gets his sample. Okay? Because systematic sampling does not require a frame, it typically provides more information for a given cost than does simple random sampling. In addition, simple not simple, but systematic sampling is easier to employ. So it's less likely to have things like interview error, right? Or picking the wrong person to be surveyed. A fourth sampling, excuse me, a fourth sampling method is called cluster sampling. Like the previous three sampling methods, this method has benefits under certain circumstances. Okay, a cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals. Here's an example of cluster sampling. A school administrator wants to obtain a sample of students in order to conduct a survey. So she randomly selects 10 classes and then administers a survey to every student in those 10 classes. Okay, so there's our 4 kinds of sampling. Let's see if we can break it down a little bit. Simple random sampling, like we talked about last time. Stratified sampling, where you break into strata. Strata means layers, right, or groups. Non-overlapping. So look, they've broken this, it looks up into men and women. And then you take a sample, a simple random sample from each stratum. And then there's systematic sampling, where this one is an example of every third person being selected. They started at 2, so you start at a random number, and then they selected every third person systematically. And cluster sampling. You break your population into clusters, groups, then you randomly select clusters and interview everyone in the cluster. Okay. A convenient sample. Now, I know we said 4, and here I'm talking about another one, but that's because look at the big caution sign. A convenient sample is one in which the individuals in the sample are easily obtained. Caution. Any studies that use this type of sampling generally have results that are suspect. So results should be looked upon with extreme skepticism. Okay. One last thing. Multi-stage sampling. In practice, most large-scale surveys obtain samples using a combination of the techniques that we were just talking about. So, an example of multi-stage sampling, consider the Nielsen media research. Nielsen randomly selects households and monitors the television programs these households are watching through a people meter. Sorry, had to get a drink. The meter is an electronic box placed on each TV within the household. The people meter measures what program is being watched and who is watching it. Nielsen selects the households with the use of a 2-stage sampling process. So stage 1, using the United States Census data, they divide the country into geographic areas, strata, right? The strata are typically city blocks in urban areas and geographic regions in rural areas. About 6,000 strata are randomly selected. And then stage 2, Nielsen sends representatives to the selected strata and lists the households in the strata. And then the households are randomly selected through simple random sampling. Nielsen sells the information obtained to television commercials and companies. These results are used to help determine prices for commercials. Okay, that wraps up 1.4. I'll see you for 1.5.